Question 8. This question is about biofuels. Complete the equation for the hydrolysis of triacid and palm oil under acidic conditions. So we're going to form this 3 will go to here to form 3CH3 CH2 14COOH carboxylic acid plus alcohol CH2. What's going to happen is the remaining, the O and H is going to bond to this, to each, and it's going to be 3 OHs. So CH3OH, CHOH, and CH2OH. 8.2. Calculate value for enthalpy of combustion data in this acid. So first things first, we know Q equals MC delta T, and we want to find delta H. So we're going to use the equation delta H equals Q over moles, and we know moles is mass over mR, so it shouldn't be too much of a problem. However, for Q equals MC delta T, M is the mass of water, not the alcohol or not the palmitic acid, it's the mass of water. So it's going to be Q equals mass of water in grams, 150 times by 4.18 times by temperature change, so 37.5 minus 23.9. Q equals 8527.2 joules. Now that's really important as well. Moles, now the moles is of the alcohol, but in this case it's of the acid. Moles is just going to be divided by delta H is equal to Q divided by moles, and the moles is mass in grams, 0. divided by 1000, 387 divided by the mR of palmitic acid. Now it doesn't give you it, so what you have to do is you actually have to calculate it from here. So 12 plus 3 plus 12 times by 14 plus 28 plus 12 plus 16 plus 16 plus 1, and you should get 256 as the mR. And then we get delta H is equal to Q divided by moles, and then we need to divide our answer by 1000 because we want it in kilojoules. Q is in joules, 1 in kilojoules, and we get 5640. And another key thing is that because temperature increases from 23.9 degrees Celsius to 37.5 degrees Celsius, it's negative because exothermic. We know temperature increases, therefore it's going to be minus 5640 kilojoules per mole to the power minus 1. And just these minor key details, M is a mass of water, that's pretty important actually. But yeah, we need divided by 1000, we need a minus sign, exothermic, temperature increases. We need to convert this milligrams into grams, we need this kilograms into grams, delta T is the change temperature. All of this is the whole reason it's 5 marks. Just tiny like tricks, traps that you just need to be aware of. So you're like, okay, I don't go through this way, I go this way. I don't use kilograms, I use grams. I don't leave as this in joules, I need to divide it by 1000 because it wants it in kilojoules. Just being aware of that, and the only way to do that is practice as many past paper questions as you can on specific type of questions or topics. We have practice, you'll get better. And then 8.3, 8.4, 8.5, 8.6, 8.3. Say how the value calculated in question 8.2 is likely to differ from the data book values. It's going to be less exothermic. Less exothermic. Why? Because of, it says other than heat loss. Other than heat loss, just talk about incomplete combustion. I've seen a couple where it's about evaporation of alcohol, they allow that. But in this case, we're not working with alcohol, we're working with an acid. So you can't really apply that to here. So less exothermic, less negative, incomplete due to incomplete combustion. And then it says 8.4, calculate empirical formula of this biofuel. So we've got carbon, we've got hydrogen, we've got oxygen, and the rest is sulfur. Find out the moles of carbon, mass over mR, so the percentage over 12, to 5.15 divided by 1 to 24.72 divided by 16 to sulfur. How do we find sulfur? Well, we know total percentage must add up to 100. To find out sulfur, we just do 100 because you know the rest is sulfur, minus 37.08 minus 5.15 minus 24.72. We get sulfur as 33.05. 33.05 divided by ml sulfur, which is 32.1. Pretty sure, yeah, 32.1. Anyway, you get this. You get these moles: 3.09 to 5.15 to 1.50, 1.55 to 1.030, and then you need to divide it again by the smallest number of moles. So in this case, smallest number of moles is 0.1030. So you need to divide each one . So you need to divide each one by the smallest number of moles, and you get 3 to 5 to 1.50 to 1. However, that's not the empirical formula. The definition of empirical formula is the simplest whole number ratio of atoms of each element in a compound or the molecule. I think it's compound. So we need the simplest whole number. So we need to times it by 2 to get 6 to 10 to 3, which is a whole number, to 2. We know that's carbon, that's hydrogen, that's oxygen, that's sulfur. So therefore the empirical formula is going to be C6H10O3S2. C6H10O3S2, and that's the empirical formula for 3 marks. Pretty nice question. But obviously you need to show your whole working in order to achieve full 3 marks of the division of the smallest number of moles and the division of the norm of the moles in general. And then it says, suggest one other possible environmental problem with complete combustion of biofuel is acid rain. And remember, sewage sludge produces greenhouse carbon dioxide. This one, yeah, acid rain, and the formula is SO2 or NOx. We could talk about acid rain / smog, SO2 / NOx, but in the mark scheme, these are the first options. Acid rain environmental problem, the formula is SO2. 8.6, I'm not sure how to actually approach this. So I'm going to ask my teacher tomorrow, and then I'll create a separate video on this. Fortunately, it won't be today. It does look a bit tricky. And then 8.7, the end of question 8. 8.6, I'll do a separate video. 8.7, the carbon dioxide produced from fermentation can be reacted with steam to make more ethanol. The equation for this reaction is 2CO2 gas plus 3H12 gas to form C2H5OH gas plus 3O2 gas. Table 4 shows some standard entropies of formation. Use the data in table 4 to calculate standard entropy change for this reaction. So delta H, remember for formation, is products, entropy of products, entropy, because you know, how do I know we've got formation data? Well, it says it right here, but even if it didn't say it, that tiny F there tells me it's formation data. If it was a C, then I'd know it's combustion data, and in that case I wouldn't use it. I'd use entropy of reactants minus products, I think. But in this case, formation, entropy of products minus entropy of reactants. So we're going to get delta H equals C2H5OH minus 235 plus 3O2, which is obviously 0 because oxygen is an element by itself. I could see a possible question where they don't include this and then some students get mixed up, not knowing that the formation of any single element is 0. So yeah, it's just minus 235 minus entropy of reactants 2CO2 2 times by minus 394 plus 3H2O 3 times by minus 242. Of course, don't just put it all in calculator. First work out what's 2 times minus 394, what is 3 times by minus 242, and then put in a calculator. Anyway, you should get delta H equals plus 1279 kilojoules per mole to power minus 1. So 1279, that's going to be positive. And that is the end of question 8. Obviously 8.6 will be done in a separate video. But yeah, that is the end of question 8.1, 8.2, 8.3, 8.4, 8.5 and 8.7.